Okay, so there's several videos for this first lesson in Chapter 1, and of course you are definitely expected to read your textbook, so make sure that you read that. It doesn't matter if you read it before you watch the videos or after you read the videos, but every chapter you need to read your textbook um, because online learning is somewhat self-directed, so you need to use every resource available to you. So we're going to talk important terms, and then we're going to talk about types of sampling, and we're going to talk about selection bias. But first is the beginning terms. So, hello, PowerPoint. So let's talk data and variables. Data are measurements of elements of a population. Elements could be people in a population or bacteria in a population or many different things. All the M&Ms that M&M Mars has ever produced could be a population. A variable is something specific that is being analyzed, such as age, height, length, color, potency, almost anything. With statistics, we can analyze almost anything. All right, so what are statistics? Well, statistics is the art and science of collecting, analyzing, presenting, and interpreting data. I say art, and your textbook author says art because there is some finesse to it. Sometimes there's no set way of doing something where you have to basically make it up. Well, not make it up, but, educate a guess. So it's kind of an art as well as a science. Descriptive statistics are the methods for summarizing and organizing the information in a data set. Those are things like mean, median, mode, standard deviation, and all that we're going to get into. The parameter is a figure that describes a particular aspect about a population. It's like a statistic, but a statistic is a figure number that describes a particular aspect about a sample. Okay, so when we're talking population, if you had every M&M that M&M Mars ever made, which is impossible because I definitely ate some M&Ms today and you can't have them back, then we would be talking about parameters. But when it comes to M&Ms, we have no choice but to take a sample. So we'll be talking statistics, and mostly we'll be talking statistics. It's almost impossible to do calculations on an entire population. The population is every single element of something. Like I said, in the United States, an element is a citizen. A sample is a representative data set of the population. All statistics are done with samples, okay? As I just said, it's almost impossible to run something on an entire population. And then you go, well, wait, what about the U.S. Census? A census takes information from every element of the population, but the U.S. Census, is it really a census? Do we really get every element of the population when we are doing our U.S. Census? The answer is no. But we do pretend that we get one from every element of the population. So people who don't respond to the U.S. Census don't exist. Now we're going to talk about qualitative versus quantitative variables. A qualitative variable can be classified into categories, like quality. Quantitative or numerical means taking on numeric values. So a quantitative variable takes numeric variable values when you perform arithmetic operations, and those operations have meaning, as in the average or the standard deviation. And we'll get into that more as we get into the actual content of the course. A continuous variable can take on infinitely many values with no space between points. Think of it like a number line with no spaces in between those points. A good example of that would be heights. You can be 34, you can be 4 feet, 0.7 or 4.89673 feet. A discrete variable is a finite number of values or a countable number of values. When I say countable, it means they can be infinite, but but you can actually classify them or count them. A finite number of values could be colors of M&Ms in your standard M&M bag. It can be shoe size, number of pets in a household. You can't have 0.5 pets. If you do, I feel sorry for that pet because well, anyway, I'm digressing.